Alright, in this video we're going to calculate empirical formula again. This time though we're going to base it on percentage or percent composition. That usually entails knowing how much percent of each element rather than knowing the grams of each element. So let's calculate one. Let's calculate the percent caffeine in coffee beans, for example. So caffeine, if you analyze caffeine, you end up finding out that caffeine has in it carbon atoms that make up 49.48%. So we're going to calculate the formula for caffeine. It contains hydrogen atoms that total 8.7% of the total mass of caffeine. And there is also, not 8.7, 5.19. Slight difference, I misread. There's nitrogen accounting for 28.85% by mass, okay? And there's also oxygen, which is making up 16.48%. So these should all add up to 100, and we probably don't have to check that they do. I'm sure they do. So this all adds up to 100. And we're going to need some molar masses for these guys. So the molar mass of carbon is 12.011 grams per mole. Oxygen, 15.999 grams per mole. Hydrogen, 1.0079 grams per mole. And nitrogen, 14.00 grams per mole. Alright, so what do? We don't have gram information. We have percent information. So what are we supposed to do with that? Well, actually, whenever you have a percentage, all you have to do is make everything out of 100. We know that carbon makes up 49.48%. That means for every 100, 49.48 of it is carbon. So we can make a conversion factor that says that we have 49.48 grams of carbon inside every 100 grams of caffeine. Caffeine. Okay, but still we don't know how many grams of carbon we have. Well, let's just say we have 49.48 grams. We can do that. And that's actually the key to solving these problems, is you just take your percentage, you can erase the percentage, and just put grams there. Put grams. So we're just going to pretend that however much caffeine we have 100 grams of it. And since we know what the percentage of each element is in caffeine, then we'll, instead of just saying percent, carbon is 49% of caffeine, we'll just say we have 100 grams of caffeine and 49.48 grams of it is carbon. So now it's just like any other empirical formula. We have 40, it's an ugly 40. We have 49.48 grams of carbon, and every 12.011 grams is 1 mole of carbon. So we want to know how many moles of carbon we have. We have 16.48 grams of oxygen. So let's figure out how many moles that is. I won't make you watch me write the rest of those. And now we can calculate that, and we get our mole information. Now we want to find which one of these is our smallest number of moles, and it looks like it's this one, and we want to divide everything by that number. So we'll divide everything by this number, and we'll get, of course, 1 mole, or 1 for oxygen, and we'll get other values here. So we get 3.99 for carbon, we get 4.99 for hydrogen, and we get 2.00 for nitrogen. So that tells us that our formula is going to be, since these are basically whole numbers, it's going to be C4, we say H5, N2O. So this would be the empirical formula for caffeine. So just to reiterate, if we get percentages, carbon 74.03%, hydrogen 8.70%, nitrogen 17.27%. We just make these into grams. We just pretend we have 100 grams of the stuff, and that suddenly our 74% carbon is just 74.03 grams of carbon, and our hydrogen is just 8.70 grams of hydrogen. And now you could just approach the problem the way you would knowing the grams of the element. So watch the previous video if you're unsure how to do that.